Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 4.2 entitled The Natural Exponential Function. And today we're going to talk about the number e and how it gets used in exponential functions. And then we're going to use it in compound interest equations. Now, any positive number can be used as a base for an exponential function. But in this section, we're going to focus just on the number e. And e stands for an actual number in math, and it has a lot more applications that you'll see in calculus. So far, you've used it with natural logs. Log base e is a natural log, so you have had experience with e. And e comes from this equation right here, 1 plus 1 over n to the nth. And as n gets bigger and bigger and bigger, as you can see in this table, we're going from 1 to 1 million. The value for that function that you get out starts to approach 2.71828. And that is what we call e. Now, e is really an irrational number, which means that it goes on forever and it doesn't repeat. It kind of repeats a little bit. It's 2.718281828, and then it starts to not repeat anymore. Okay, so we just usually use 2.718, the first three places after the decimal there. Now, sometimes e is kind of a weird, funky number. You know, it comes from a very specific equation. And so sometimes students say, well, why do we use this? But it does have a lot of applications, and it really has a good application when we get to interest. Instead of having a big complicated equation with 1 plus r over n, we can simplify that all the way down to just e. So when we're dealing with our exponential functions, any function that has an e as a base to the x, that's called your natural exponential function. Okay, and if we graph it, since e is 2.718, it has to be between 2 and 3. So when you have e to the x, it has to be between 2 to the x and 3 to the x. So in this picture, you can see 2 to the x is graphed in this green line, and 3 to the x is graphed in this blue line, and then e to the x is between them. It's that red line right there. Okay, so let's take a moment and just make sure that you know how to use e in your calculator. You do have a e button, so you can type in e to the third power, and you should get 20.08554. And then when you're evaluating part B here, you want to do e to the negative 0.53. So make sure you do that part first and then multiply it by 2. So again, don't forget about your order of operations. You should get 1.17721. And then for part E, you're going to have, or for part C, you're going to have e to the 4.8. So you can take e to any power. Over here we had it to the nice even whole number, or nice whole number of 3. Here we have a decimal. Okay, here we had a negative decimal. But when you raise it to the 4.8, the power of 4.8, you get 121.51042. So your book will have you do some problems like that in your homework just to practice your skills on your calculator and make sure you know how to use E and how to type it in and how to evaluate it. But how we really use it is in equations such as this one. And here we have an infectious disease that begins to spread in a small city with a population of 10,000. After T days, the number of people who have succumbed to the virus is modeled by this function. And we'll talk at some point about how they get these functions. Sometimes you just see these equations, these word problems, and then you see these equations, And you're just expected to say, oh, yeah, that's how they got the equation. Yeah, they just gave it to me. But really, they would have to count day by day how many people were ill, and then they'd have to chart that, and then they would have to graph it and find their line that goes through those points, and then work to find a function that fits that line. Okay? So they don't really show you that part, but they explain what's going on, and then this is the function that they got from all of their data. So now, how many people were initially infected? So that would be at time of 0. So we're going to put 0 in for time. So we'll have v of 0, and we'll have 10,000 over 5 plus 1, 2, 4, 5 times e to the, let's see, and now if I'm putting 0 in there, anything that I take times 0 is going to be 0, so that's going to be e to the 0 power there. Even though it's negative 0.97 times 0, that's just going to end up being 0. And e to a power of 0, anything to a power of 0 is 1. So 1 times 1245 is 1245 plus 5. So you get 10,000 over 1250. And then when you divide that out, you should get 8. So there were 8 people who were sick initially when this disease began. That's the amount of people who were originally sick. Now for part B, we're going to take that same function and we're going to apply it to figure out how many people were sick after 1 day, 2 days, and then 5 days. So we have to do V of 1 and V of 2 and V of 5. So when we do this in class, I'll probably break it up a little bit, have different rows, do different equations. But basically, we're going to substitute that information in to our function. So we had 10,000 over 5 plus 1245 times e to the, now we had, what was it, negative 0.97. Okay, so negative 0.97 times 1 is going to be negative 0.97. Now again, these problems aren't so much problems about actually, I'm not sure on the right phrasing here. It's not so much on the calculation and getting the right answer so much as it is making sure that you're able to apply this usage of e. So again, do the order of operations here where you've got e to the power of negative 0.97, get an answer, multiply that by 1245, get an answer, then add the 5. So a lot of times students try to type this stuff into the calculator in one big giant string and they end up getting the wrong answer. And they say, but I typed it into the calculator right. But the calculator only does what you tell it to do. So you have to tell it to do the correct order of operations. So that's why it's best to do it one step at a time. Now when you do simplify that whole denominator, you should get 476.96, which will get you about 21 people. Remember, you have to have whole people here. Okay. For V of 2, again, we'll have 10,000 over the 5 plus 1245 times e to the, now this was negative 0.97 times 2, so that's going to be negative 1.94. So I'm doing that simplification there as I'm substituting it in. Then you do e to that power, get an answer, multiply it by the 1245, get an answer, then add the 5. And you should get 183.91. And that should get you about 54 people when you divide. And then for V of 5, so we're going to take the negative 0.97 and we're going to multiply it by 5. So we get negative 4.85. Okay? And again, take e to that power, get an answer, multiply it by the 1245, get that answer, and then add the 5. And then do the 10,000 divided by, in this case, 14.75. Now notice that our denominator is getting significantly smaller even as that value that we're substituting in just increases from 1 to 5. Look how much smaller that value got. That's the power of e that you're seeing. So when we divide here, we get 678 people. Now, that would be really scary. If this was a real virus, after just 5 days, you go from having 8 people to 678 people infected. That would be really scary if this was really happening. You'd have 678 people at a hospital in a town, all with the same mysterious illness. That would be a very severe health crisis, epidemic level type thing. Okay? Now for part C, they want you to graph this function and describe the behavior. So we got to go back to our very original function. And when you put it into your calculator, make sure you put the numerator, the 10,000, into your calculator in parentheses, and then do divide by, and then put the whole denominator, the 5 plus 12,000, or 1245 times e to the negative 0.97 times x, put all of that in parentheses too. So numerator and denominator get put in parentheses. Now you have to adjust your window on your graphing calculator. Now your x min and your y min can both be 0 because that's, the number of days and how many people, okay? And then your x max, if you set that to about 20, and your y max, set that to about 3,000. So that means after 20 days, we might have 3,000 people. Okay, we're just kind of estimating right now. Okay. But I mean, after 5 days, we had 678 people. Okay, so you have to be able to at least see that value. You have to be able to see 5 and 678 on your graph. Okay, so you have to adjust your y value already up into the hundreds. So if we're going out to 20 to see what the graph is going to do, we got to go really, really big on the y values. And when you do that, you should end up with a graph that looks about like this. So it starts out really, really low, and then you can see that it grows super fast, and then all of a sudden it tapers off. Now you can trace the function, and you can see the x and y values at the bottom of your screen. And when you get over here, you'll notice that these values start to level off at around 2,000. So after so many days, it starts to level off. And we want to figure out how many days that's actually happening. So again, if you trace, you start to get to this level part right about here, okay, where it really starts to level out. That should be at about 12 days. So at 12 days, the, what was I want to say, the disease levels off at 2,000 people that are affected. Okay. So this is the advantage of the graphing calculator, is that it can give you this type of information once you get that function in there. So again, this is making sure that you're able to put a function into your graphing calculator, even a really complicated one, and adjust your viewing window so that you can see it. Okay, last example then is to talk about continuously compounded interest. So all of these examples are going to have the word continuously in them. And this formula is basically the same formula that we had before. In the previous section, we had p times 1 plus r over n to the nt. So what they're going to do now is they're going to take this whole chunk of stuff in parentheses, this 1 plus r over n, and they're going to simplify it down to be e. Okay, so they're kind of replacing it. And instead of the n, they're going to call that your r. Okay, so this is how we get that equation. So A is still the amount, P is your principal that you're putting in, R is your interest rate, and T is your time. Okay, in this case, it's number of years. And then we're going to use base E. Makes it a much more simplified equation, and it gives the amount when the interest is compounded at every instant. So that's the advantage of E. That's what E lets us do for this type of a situation. So example 4, last one, says to find the amount after 3 years if $1,000 is invested at an interest rate of 12% per year, compounded continuously. So there's that key phrase or that key word that we're looking for. So that tells me I'm going to use A equals P times E to the RT. Now I remember this equation because it spells PERT, P-E-R-T, and that's a type of shampoo, PERT Plus. Okay, I don't even know if they make it or sell it anymore, but that's how I remember that. So that's a good way to remember it, that it spells PERT, because that tells you the order that you're going in. So we have our $1,000 for our principal. E is going to stay E. Our rate, we have to make it into a decimal, so 0.12, and our time is going to be 3. Now again, you do have to simplify this. Do your order of operations first here. You have to do 0.12 times 3, so that's 0.36. Then you have to do e to the 0.36 and get an answer, then multiply by the 1,000. Okay? There's no shame in trying to type this into your calculator one step at a time. You're going to be more accurate and you're going to get the right answer if you do it one step at a time and follow your order of operations. The students who miss these types of problems are the ones who just type it in the way it looks, 1000 E 0.36, and hit enter, and the calculator doesn't do the correct order of operations because you haven't told it what to do. Okay? So if you type this into your calculator correctly, you should get $1,433.33. Okay? So here's your homework for tonight so that you can practice these concepts. They should all have E in them. And if you have any questions on how to use your calculator and how to use E and how to adjust your viewing window for your graphs, come on in and see me before school.